Well, good morning and welcome to a really windy, blustery, late summer, beginning of autumn day here in Cambridge. Now today, we're going to talk about fence-mounted solar panels. I want to give you an update on how they've been performing. I want to show you exactly what you could expect if you were to roll out a system like this. And specifically, if you're renting your property and you're thinking about a balcony mounted solar system, how long would it take to pay for itself? So today I want to give you an update on how the fence mounted solar panel system has been performing during the month of August. But more importantly, I want to be able to give you some information about what it would cost to build, what it would cost to set this whole system up if you were in a rental property. What if you can't put solar panels on your roof or batteries in your garage and you need a system that is non-destructive, that you don't have to drill holes in the wall, but you still want the benefits of solar? Well, that's exactly what we're going to do today. We're going to take the generation figures from this system, we're going to cost out what a similar system would cost to put into a rental property, and we're going to see what the payback period is for that particular system. Now, here's a quick overview of my system. So behind me you can see 4 panels. 2 of them are actually connected to a completely separate system, so ignore those for now. But there are 2 panels here on this side of the garden. This is facing roughly east, and there are 2 panels behind me which are facing roughly west. So these panels capture the morning sun, and those panels capture the evening sun. So they give me a roughly equal part of the day, that those are generating on one half of the day and these are generating on the other half of the day. Now all 4 of these panels are connected via wires that run down my fence. Those wires then go into the back of the EcoFlow Stream Ultra. Now I should say at this point, this is not a sponsored video. EcoFlow did provide me the Stream Ultra. That was for a previous video. This video, they have not asked for it, they have not seen it, they have not approved it. This is my thoughts about how you could deploy a system like this. And of course, you can take the same methodology that I'm about to give you and you could apply it to any other manufacturer's systems. Okay, let's head into the office and I'll show you exactly what all the individual components cost. We'll look at what did the system generate this month, and we'll figure out how long is it going to take to pay for itself. Okay, we're back in out of the wind. Now, the stream system itself sits down here underneath my desk. You can see here we actually have 2 units that look identical. One is the system that has the inverter that connects to the panels and generates the electricity. The other one is just an add-on battery. For the purposes of today's calculations, we're just going to focus on one system. And we're going to go with the model that is a slightly lower version down the range than this one. This is the Stream Ultra. We're going to go with the Stream Pro to try and keep the costs just down a little bit. Okay, let's take a look at the whiteboard and let's work through what you would need to build a system like this. Okay, before we dive into the figures, let's be very clear here. Not everybody is going to be able to do this. There is going to be some upfront investment in a system like this. And I understand not everybody's going to be in a position where they can afford to do that, even at the relatively low costs of a balcony system compared to a domestic system. But what we're going to do is we're going to take a look at all the constituent components that are needed to build this system. So what I've done is I've been onto EcoFlow's website, I've been onto Amazon, I've looked for all the deals that are available to try and get a rough estimate of what I think the price would cost. Now I know it's a little bit difficult to see this on the screen here, so I will put it on full screen for you now, but each of these is a different part and some things you will need multiple of. So there is a bundle here which is the EcoFlow Stream Pro. So that's a slightly cheaper version than the Stream Ultra. The only difference between the two is the Pro has 3 MPPTs, the Ultra has 4 MPPTs. If you don't know what an MPPT is, I'll put a description up on the screen now. Please pause the video, feel free to read it. But it's basically how many inputs for solar the system has. We're going to add a couple of extra panels, we're going to add some mounting hardware, we're going to add some cabling, and then when we total all of that up, we get a price of £1,653.97. Now again, Black Friday's not that far away, so maybe there'll be some deals there. So if you are looking to get a system like this, I wouldn't rush to get one today. I'd look for a really good deal. But once the system's all installed, my system was able to generate 93.81 kilowatt hours in the month of August. Now that doesn't seem a lot, let's say 100 kilowatt hours rounding it up. But don't forget, my panels are mounted vertically on the fence. Just been able to increase that elevation off the fence panel by 10 degrees would add significantly to that number. Now the reason I don't do that is, as you saw earlier, it's quite windy around here. Being in East Anglia, it's very flat, so the wind tends to howl. I don't want the wind to get behind the panels, so that's the reason I have them in the almost vertical orientation. But even if you could increase that inclination to 5 to 10 degrees, something like that, this number would go up significantly. But we're going to use this number for our calculations. So we generated 93.81 kilowatt hours with that system in August. Now the reason I like August as a number is if you average out the whole year, August tends to be about the midpoint. So it's nowhere near as good as May, June and early July, but it's certainly not as bad as November, December, January. So again, it kind of gives you that sort of midpoint. So we'll use 93 as an average, but again, you can adjust the figures to suit yourselves. And then the EcoFlow app really has this really nice screen where you put in what a standard tariff would cost, and it tells you exactly how much money you've saved this month. So my 93 kilowatts, if I was to buy that from Octopus on their 12-month standard tariff, it would cost me about £26.27. And I haven't had to spend that because all of that solar has gone into the battery in the EcoFlow Stream Ultra, and then we've discharged that battery into the house in the evenings when we need the power. So we would have had to buy £26.27 worth of electricity, which we haven't. We got basically for free from the sun. So if we look at that, we've spent £1,653.57. We've saved an average of £26.97. I'm making the assumption that electricity prices won't go up just because it makes the calculation so much easier. But in reality, we all know energy prices are going to go up. They've been going up for ages. They're going to continue to go up. So you might actually save more if the energy prices are higher. But for now, we'll just keep it at what it is today. So based on all of that, it would take 63 months to pay for itself. Now, what's 63 months? Well, if we work that out, we divide that number by 12, that is 5¼ years. Doesn't sound that much. And the real advantage here is if you're renting your property and you decide to move, you can pack all of this kit up and you can take it all with you. Because you don't require an electrician to install it. If you're competent and you can install a plug, you really should get it installed with a fused spur. That's per the electrical regulations. But if you go on Reddit and you go into the EcoFlow forums, just about everybody is putting a plug on the end of the cable and plugging it into their home. So again, everything, the battery, the inverter, the panels, the mounts, everything can just move from property to property with you. So once you've invested your £1,600, you've got a system that has paid for itself in 5¼ years and will continue to pay year on after that. These batteries, with the number of cycles that they can do with the modern battery chemistry, have a lifetime of over 6,000 cycles. So you're looking at well in excess of 10 years before you should start seeing any battery degradation. And if anything that I've seen with batteries over the last 20 years is those are always super conservative estimates. Just to give you an example, my old Tesla Model S was 10 years old. It had been supercharged and charged to 100%, all the things they say you shouldn't do with a battery. And after 10 years, it had lost roughly 7% of its capacity. So I wouldn't worry too much about will my batteries last. Once they've paid for themselves, they'll continue to deliver year on, year in. Anyway, I hope you found this interesting. I hope this is useful. If you've been on the fence, pun intended, and you're looking at either a fence mounted or a battery mounted solar system, this is the kind of number you can be looking at, about 5.5 years to pay itself back. That is significantly less than my roof mounted solar system, because that would take somewhere in the region of 8 years, maybe 8.5 years to pay itself off. This will pay itself off in about 5.25. Anyway, that's it for today's video. I hope you found this interesting. If you have, leave me a like and a subscribe below. It would be greatly appreciated. And if you have any questions about it, hit me up in the comments. I'm always happy to chat. With that, I'm going to sign off, and if I'm lucky, I'll see you back here real soon for another video. Take care. Bye-bye.